right. Hello, good morning. Welcome to the conference talk from Roland and myself. I'm Matthias Wessendorf. We both are engineers working at Red Hat, and we actually are active contributors to the Knative project. Knative. Knative is a Kubernetes-based platform to actually manage modern serverless workloads. All right, let's take a step back and realize or see what serverless actually means. What I've written here on this slide is basically a slight modified statement or definition from the CNCF, how they see serverless within their serverless working group. So serverless computing refers to the concept of building and running applications that do not require server management and describes a fine-grained deployment model where applications are uploaded to platform and then executed, scaled, and built in response to the exact demand what's needed at the moment. So the only section that I was removing there is the bundling as one or more functions, because overall the concept is just not limited to functions themselves. All right, I'm just curious, serverless, is this already reality for people here in this audience? All right, so anybody using a particular vendor like Azure or AWS, Lambda? A few of us? All right. So let's see. Serverless. Oh, well, AWS Lambda. It's just glorified CGI bin, right? Changed my mind. So the traditional approach on these different vendor platforms are you write your code, your Node.js function, you upload it somewhere, and then it's executed. And all of the scaling and stuff is handled for you on demand. So changed my mind. But I guess you're also curious now how Kubernetes actually fits into this picture. And that is a question, Roland. Can you explain how that works?
Yeah, sure. Glad that you ask. That's very nice. So let me explain. Let's try this. So now we are landing serverless on Kubernetes, and we are reaching the Knative island, more or less, like we see here. So what is Knative? Actually, Knative is a kind of a Kubernetes-based platform for build, deploy, and managing serverless workloads. So there are three parts actually in Knative. So Knative itself is around, I think, 1 year old, or I would say.
A little bit older.
A little bit older than 1 year, so it's still quite a young project. And as mentioned, there are three kind of pillars which constitute Knative itself, the three Knative components. First of all, it's about building your serverless workloads or payloads. There's the build aspect which takes your source code and creates a container image out of it. And so this was part of Knative. It's all realized via CRDs, as we will see later in the demos. And yeah, then you have your container image, and the next step is, of course, how you can serve this image to the world, how you can deploy it. So this is all about Knative serving, which is more or less, there's a request-driven, so there's a kind of typo in it, which also one of the key aspects of serving is that it can scale to 0, as we will also see in a second. And so you have a very flexible way how you deploy your workload. And finally, there's eventing, Knative eventing, which is more or less a common infrastructure for consuming and producing events. Really, you have various triggers how you can feed your services at the end. So actually, these are the three pillars. And as you have read the announcement of this talk, so we wanted to talk a little bit about Knative Build. But unfortunately, since this announcement happened and today, there has been some movement within the Knative project, and Knative Build is currently on the way out of Knative itself, because it's going to be replaced by Tekton pipelines. And yeah, so the question is, of course, why it is like this. So then we don't have build anymore as an inherent part of Knative itself. So what we are doing then, let me show you this. What happens is, so we have a very short section on Knative build. Actually, we have no section of Knative build, but
zero.
It's out there, and this is the relevant GitHub proposal or issue, which means that in the next versions of Knative, there will be no build port anymore, probably. So this, you see, the issue is still open, so there are still some discussions, but actually I think that the consensus is really that it goes out and should be replaced by Tekton pipeline. Tekton pipeline has a broader vision. So it means really that you can create your pipelines directly, so not only building an image, but do all sort of CI and CD stuff with the pipelines. And then it's a kind of a little bit of inversion, that it's not Knative who's building the image anymore, but it's something outside of Knative which builds the image, which puts your code into container images, and then it's Knative which is running it. So you will be triggered from the outside. So it's not so that Knative have everything under its hood, but it's just a part for building stuff. Okay, let me continue. So now, this was my building part, sorry for that, but actually this is reality and I can't change it. Let's talk about serving, which is even more important. And let me just jump onto what this really is. And actually, Knative serving has some very key characteristics, key features. And this is especially everything about routing, so that you can flexibly route to your various versions of your applications from the outside. Scale to zero is one of the key killer criteria of Knative serving, which allows you really to scale down to nothing your application, so that it also doesn't cost anything, and so that you are able to keep it in the background. This is one of the key features of serving, and for any serverless platform, I guess. And then also tracking revisions over time, so that you have a kind of revision history that gets in. This is one of the key concepts. I already mentioned some of them. There's the separation of code and configuration. So you have the code, which is in your container image, as I mentioned. But then there's also configuration. And every time you change your configuration, you get kind of a snapshot in a so-called revision, which is also stored in Knative serving. You have this scale to zero. You have traffic splitting, which is very interesting if you have different deployment models, like, for example, canary deployments or blue-green deployments, where you have two versions of your applications running at the same time, and you want to distribute the traffic from the outside to these versions. And one has to say that Knative serving is not really a full deployment model for everything. So actually, there are some severe restrictions how your application has to look like. For example, so it's Knative serving only allows a single container to be deployed. There are no state. There's no persistent volumes in the background, and also you have only a single container running in there. So it's a simple thing, but actually it's also, as I mentioned, so you mentioned functions earlier, so it's also targeted, of course, for this FaaS world, where you have these kind of simple applications, and that's probably one of the reasons why it's that restrictive. But there's also a good point that these services can be really seamlessly integrated into kind of eventing, which we will see later. So service can act as an event consumer, but also, this is one of the key features and how this realized. So in Kubernetes, every extension is probably these days is realized by a CRD. So you have custom resource definitions which provide extra features to Kubernetes. This is equally true for Knative serving. So what you have is a configuration object. So actually you have this, on the top you have a service object, which is kind of the way this here, with which you interacting. And under the hood there are other CRs created for you. Typically you can create them also on your own, but typically you do not really bother with them. So you have a configuration which reflects your application's configuration, and each time you change it, you get a snapshot which is called a revision. And so you have several revisions after in time, and these revisions are really immutable. So you cannot change a revision afterwards. So if you change the configuration, you could just get a new revision. And in front of these revisions, there are routes which really have this traffic split capability, so you can really realize certain features like canary, where you only put a certain portion of your traffic to a certain revision, but the main traffic goes to the main application like that. And it's important also to know that this service is not really the Kubernetes service, because this sometimes gets really a lot of confusion. So it is a Knative service, so you see the difference by the API group if you use them, and you can also use when you use kubectl, you typically use the shortcut which is KSVC, which is just a shortcut for Knative service. Okay. Then is one important thing. So actually, I'm describing now the latest version of Knative. So Knative, there was some kind of evolution over time. Even in the last year, there were several variations of the CRD format, of the schema for that. And now I'm going to show you the latest one, which is also called Alpha V1, but actually there was some evolution within one version, but now I think beta 1 is due to today, I guess, or tomorrow. So I think serving is
during the night.
Yeah, exactly. So the newest version will come out, this night. And what you see here on the left side, yes, you see a deployment as you know it from Kubernetes, and and this is how a service looks like. So actually, this is Knative serving, which means you strip away a lot of boilerplate, which is taken care by you by Knative. For example, you do not need any service or ingress or route object in front of your deployment, because this is automatically created for you by Knative in the background. And then you need also some certain replicas, because all the scaling is done also for you. It's completely managed. You don't need a selector and also not a name. So you see that it gets denser, and this is actually the new version of this CRD, because before that it looked a little bit different. Okay, now I have a little bit of talk, so I have 5 minutes for a demo. Before I start, so let's switch over to the terminal. So what I have here now is just a minikube, so you can install Knative on any Kubernetes cluster. So for simplicity's sake, I'm just using minikube here. And yeah, so what I want to show you is a simple command line tool, which is called KN. This is also part of Knative, which is currently developed, and this helps you in creating these CRDs under the hood. So this is more or less kind of a shortcut for creating CRDs, and I'm just showing you how you can use this. Oops, sorry.
The watch.
Yeah, thanks. So let me watch here the pods. So actually I have no pods running here. You see on the top side that pods, and now we just creating a service named Lotto, which just draws the Lotto numbers for you, and a reference to the image there. And if I start that, so I see that it's already existing, so I forgot to clean up before. But you can, so I also can easily show how to delete stuff. But it's interesting, you see that there's no pod running, so actually this already has scaled to 0 because I haven't done anything, but it's still there. The service itself is there. So let me delete that, and now create that again. You see that the command by default waits and blocks until it's really up and running. So now you have one pod running there. This is, of course, not very impressive because you can do the deployment as well, of course. You see the URL here directly. And what I do, so if you would use OpenShift, you would get really already a routed URL there. But we are not, so we have to make some trickery. So I'm extracting, so this is not important, it's just a hack to get the IP address. And then I make a curl like that, and then I get here the number. So just take a picture because this will be the number from next weekend. Okay, and now let's put some, what I can do now next, so I can also, of course, look into the service describe. So we can look how this looks like, and you see here that you have various status, but also interesting that you have one revision now. This is really the revision which is running behind that. You have certain annotations. And now let's create a new revision. So actually what we want to do is just to update this service. And we say concurrency target equals to 1, which means that one pod only manage one single request coming in. So there's a concurrency model, and the autoscaling always happens on concurrency on HTTP request. So when I said that, then every time a new parallel request comes in, a new pod scales up. Of course, this is very artificial. Typically, we have, of course, more, like 100. I think default is 100.
Yeah.
Yeah. Okay. So now I'm updating this thing, and now let's see the revisions here. And you already see that there's a new revision now, which is with number 2. Actually, the hour is a little bit screwed from our minikube server. And now already every 100% of the traffic goes to the new revision. And now then you can tweak that and say, okay, I want even then the old revision like that, which has the old limit, which was 100, and the new one has a concurrency limit of thing. And we can quickly test that with a tool called Siege. I hope this is working. So we are seeing that.
Sure?
Yeah. Yeah, actually, the last time I tested this, my whole minikube was killed afterwards, but let's try that for a second. So let's be brave. So I'm just hoping that this already was enough. So this is what I want to show you. Yeah, you see. Now you see that there are new containers coming up already running. So now I have 3 containers. So you see the number, this 9L, RN, W, which specifies the revision. And now there are 3 containers just processing my request. But of course, after now 2 minutes, they will scale down back to 0. So this is very dynamic. You can tune it. You can also say a min scale, which means that you want to have a certain number of pods always running and don't scale to 0. So this is all configurable via this tool. And yeah, so of course, you can also look at the CRDs themselves, like here. Now you see that you have these 2 CRDs, and you can also manipulate them than any other Kubernetes CRD. But actually, this command line tool is quite convenient. So as I mentioned, I just delete that service delete again. And now let me fire up a final service, which is service create. So this is a server which is called events thing. So this is what you told me that I should do. I have no idea what I'm doing now, but actually.
Me neither.
Yeah, but so let's fire that up here. So we can, this display, again, it waits here. Let me start a watch on the pods there.
Kube control.
Oops, sorry. This of course, oops. Kube control, get pods. And yeah. So you see that there's something running, it's our service, but also something else, and I wonder really what this is. Maybe you can explain it now, what it is? This would be awesome.
Sure, let me try.
Yeah. Okay, let me just switch to the eventing thing.
Thank you.
And yeah, so.
All right. Thank you. So what we saw so far is basically the capacity of doing scaling, canary, or traffic splitting, etc. How to make this thing like useful in combination where you want to run like complex data processing pipelines. So this is where Knative eventing is a sub-project. This is where it offers you some help there. Basically, it can be seen as the universal subscription responsible also for delivery and management of events. So some are calling capacities of Knative eventing also the eventing mesh in your Kubernetes-based cluster. And it has a few features. One of the big benefits is here that you can actually use the event orchestration. Being running on Kubernetes, it does have, of course, declarative APIs where you can basically define event sources that send stuff over the wire where you can consume them and also filter based on different triggers. And it also then leverages the ability that once there is an event, it is forwarding it to the other capacities like the Knative serving services that you saw. So you can have like very high dynamic data processing pipelines. Something to note here is that the components in Knative eventing are native to CloudEvents. So all of the sources or importers are reading from a third-party system and translating them into CloudEvents, so this is natural here. You can also extend Knative eventing. One of the examples, and that's most likely the biggest point for users, is you can create your own custom event sources. They are now being renamed to being importers. There's a bunch of them already available in the various repositories. So there's one for GitHub, there's one for Apache Kafka, there's one for, I don't know, RabbitMQ, etc. There's a bunch of different sources. Well, importers, the trick that they do is you can connect to a third-party system and then receive events there, and they basically put the payload into the envelope of a cloud event object. The other pluggable implementation detail here is that there's various channels. It's like a bus between the different components, like from my importer to a service. The communication is done through a channel, and there's various implementations out there. The eventing core YAML release file contains the in-memory channel, which is the default. However, you can also replace that by using a channel that's backed by Apache Kafka. So all the messages that go in are persisted on topics, and as soon as you read, they're consumed from a topic. The same is true for other storage technologies like Google PubSub. So Knative importers, well, this is really the opportunity for you to actually integrate with your third-party system. It doesn't need to be something fancy like your Apache Kafka cluster. You can also use that to actually read some statements from a database. You then use the select query, whatever you read, you basically put it into a cloud event object and then route it forward to the configurable sink of a Knative source or importer. So it consists of two different planes. One is the control plane and one is the data plane. The control plane basically would, in the case of Apache Kafka, describe what actually topic subscription is used. And the data plane there would be that, okay, I need to actually pull events from Apache Kafka in order to make them available as cloud events inside of my Knative eventing application. Besides pull, there's also support of a push model. You saw earlier on the other slide something with GitHub. So there's actually invoking you based on GitHub events. So there's a source for that as well. And it does the validation of the events if they really make sense for your application case or the format of the protocol underneath. You can also build your own source. There is two official ways. One is to build a full CRD using something like Operator SDK or KubeBuilder, or you can use a more convenient vehicle for getting started, like the container source. That is a CRD from Knative eventing that allows you to run any arbitrary container as the source. Or if you don't want to do that, you already have some event stream, you can just emit the events, the cloud events yourself, and emit them to HTTP, like hard-coded to a URL of the Knative eventing broker. So that's a little bit more tricky. All right, a quick overview what you could use Knative eventing in order to build like complex data pipelines there. here's an example where I have my Apache Kafka cluster running somewhere, and then I'm using the Knative importer for Apache Kafka. So in that configuration for the Knative Kafka importer, I basically say my cluster is there, bootstrap servers, the topics that I'm interested in, etc. Now it is receiving events and translates them into CloudEvent. So I read them from this third-party Kafka cluster, and then I'm basically performing an HTTP post of this new CloudEvent, in this case to a channel. I can also forward them to other API components that are there, like a broker, a sequence, or a vanilla Knative serving that Roland was showing before. In case of the channel, the channel can have multiple subscriptions. So the diagram here is showing that the first channel has exactly one subscriber. I could have multiple ones that are also reading all the messages that are available on that particular channel. In case of a real channel being implemented by something that supports like actual storage, like Apache Kafka, the messages underneath, they would be stored into some wildcarded topic name where the topic, Kafka topic itself is consistent of the name of the channel, the namespace that is in there, and some Knative eventing -Kafka prefix. And now, the service that is described here as a data processor A is then subscribing to the channel, and what it does, it is basically receiving the CloudEvents objects that are then distributed from the channel controller to that processor. So now the processor is receiving these CloudEvents in a HTTP post request and is doing some data transformation, and once it is done with the data transformation, it does actually return a response. You can configure the subscription that the response, the HTTP response, goes to a new channel called the reply channel, and then the game basically goes on. So you can,
Doesn't go really.
Okay, it doesn't work. All right, then, then you can have a different subscriber, in this case, processor B, that is listening to the modified messages on the second channel. So processor B does what it wants to do, and also does a return of an HTTP response, and that is put by the description of the subscription to a different reply channel. And there we have a final event receiver that is just configuring to the messages that are transformed through this data chain and is then storing them in some database, in this case, Redis. So this is nice, but does involve a lot of YAML writings. There's good news. With Knative Eventing 07, that is due tomorrow morning, 1 a.m. or something like that, there is a new kind sequence, which basically allows you a more convenient, simpler way to describe your data flow. So you would have your YAML for the sequence, and you basically say, okay, I have step 1, I have step 2, etc., and then you describe where you are basically delivering the messages that are being returned from the last step in your sequence. And here you could still reuse the old receiver that is there that does some storage to a Redis database. The YAML would look like this. The Knative source would be described. I have some data inside of the spec. The important part is here the sync underneath, and it is referencing to a kind sequence with the name sequence. This is a hello world cron job source that like occasionally puts a message onto the sequence, and then there I have my sequence, which is basically named sequence. It has a channel template there, so it says what's the persistent model for the channels between the processor A and processor B. And then I describe basically the steps as a linear process here. I have a processor A and I have a processor B, and here I say the reply of the last guy in this references of steps is delivering the final outcome of the data pipeline to a vanilla Knative service, serving service called receiver. So this is a little bit of simplification to the original model. So this is something that is coming, is usable today already, but the official release is tomorrow. And then I have one more thing to say here. There's a few more resources inside of the API. There is a broker and there is a trigger. The broker is really the heart of the eventing mesh or the delivery system. You can connect various sources to it, and internally behind the scenes it uses channel. If you wish to use Apache Kafka channel, then it would be automatically stored and persisted in Apache Kafka. The interesting bit here in combination is a trigger which allows you to actually filter. So you can, the eventing mesh or the broker has all of the events that are available there, and then using a trigger you can also distribute various event types or from limited event sources, you can forward them and filter and query for certain events there. And then there's also another type that's new in the last release. It's the event registry. It's an own event type CRD. Allows you with the discoverability of events so that your application can check what event is interesting in. And then last but not least, the sequence I was showing you already a little bit detailed there. That is part of the next release. Is also very flexible that you can basically chain a bunch of different services like Knative serving services. And you can sync to Knative services, to channels, to sequences, or to the broker, so that your sequence would then feed the broker, and you could then use the trigger again and distribute a filtered event stream to any other application there. Broker and trigger, how would that look in reality? I was able to actually use this diagram from Ville Eikas. He's working with me on Knative eventing as well. He was creating it, and it was so nice for him that I could reuse this slide because it's really great. I have two different sources here. One is publishing red events, and the other one is publishing blue events, and they both speak to one broker, right? The blue and red events are going to the same broker. Now I have two different triggers here defined in my application. I have one trigger that is only filtering for red events, and I have another one that is filtering for blue events. So now this trigger then is basically only receiving the filtered events and therefore forwarding. So the service number one on the above one is just receiving the red events, while the other one is receiving only the filtered blue events. However, both of these different types, the blue event or the red event, they also came from the same broker. So this is a powerful mechanism that you can basically filter out of your overall eventing mesh. All right. Oops.
Update.
I don't know how to use a Mac.
Should I do? I always do.
Yeah, sure.
Okay.
All right, good. Roland was already defining a service for me that is used at the end of this demo. What we did in advance is we were injecting a Knative eventing injection field into the namespace, and then we have a default broker that's coming up. The default broker consists of two different parts. There is one that is performing all the filtering, and there's one that performs all of the ingress, so all the events that are going in there. Now let's see what else we have. All right, we do have an event-based demo that is receiving Kubernetes platform events and is distributing them to the service that Roland was deploying with the DK and command line tool. Kubernetes platform events, in order that I can actually run that, I need a little bit of extra rights here. Let me see how my service account looks. So what I'm doing here is, I have a event a service account called event SA. It's in the default namespace. There's a cluster role event watcher. And then I'm basically asking for permissions on the event resources with the list get watch. So it's read only, and then I have the cluster role binding for my service account there as well. So applying all of this is basically allowing the event source later to actually come up and go live. Okay, I have my service account now applied. The next thing is I need to show you what the configuration of the source would look like. So this is the CR file for the API server source. It lives in the API group sources eventing. This source does have, so they are still named sources, but that's going to change eventually. So test event is the name. And then I have a reference here on my service account there. And what I'm describing here in this API server source is basically that I'm interested in all events, V1 platform events there. And I perform a sync to the broker. So all of the Kubernetes platform events that are there will be then forwarded to the broker, being CloudEvents, okay? Now let me apply this file. That doesn't work. Okay, what we see here is, based on my creation or apply, a API server source is being implemented. So it's now sitting there and watching for various Kubernetes platform events. And now let's see what's the magic there in order to get this routed. So that's the last piece of this demo. It is a trigger. And the trigger is basically having inside of the specification, it has a filter field and has a source and type field. Underneath, there's an actual type. What I'm doing here is I filter for events from this Knative API server source, and it is asking only for resource add. There's also list and update and whatnot, but I'm only interested in filtering for everything that has been added. And then last but not least, I am reusing the service, the Knative serving service called k8s-event-display as the consumer of all of these events that are there. Now, let me apply the trigger. All right, I have created the trigger, and it should, it does spin up a pod of the Knative serving service. Why is that? Because there were already some Kubernetes platforms events. While I was doing that, I can also do a kubectl run. Sorry, let me show you the logs first. Okay, logs, get F. Oops.
No, cancel. Das double. Nochmal markieren. That's it.
Okay, yeah, I really don't know how to use a Mac. I use a real machine. Yeah, no kidding.
Yeah. Okay.
Sorry for that. You see there's two containers running on a particular pod. I'm interested in only the user container. That's the source code that I have written or that we have deployed for the service. The other one is from Istio. And what we see here is we get some metadata. So subscription reconciled, this is a event that's actually from Knative itself. And we have some validation here. So we see here's a cloud event. It is a valid cloud event for me. I get some information of the actual type of the cloud event itself. And I was only querying for add resource. So I get this here. There's some of the cloud event extra metadata like extensions that we run on Knative. And then in the data field, what we have here is we get the actual raw event that you may know from working with the kind event type. All right. That's concluding the demo.
Yeah.
Shameless plug for Roland.
Yeah, here it is. So there's a book, and there's like a chapter also about Knative. So just if you're interested, it's quite new. There are also tons of other stuff in there. So, but this is now the commercial, and it's now over as well. So that's it. So by the way, I can recommend the book there.
Really?
Yeah, I can do.
Does it talk about build?
Okay, I think that's all what we have for now. And we might have even 3 minutes for questions. Are there any questions? No questions. No questions? Okay, then...
I guess that's because there's food outside.
Yeah, maybe. Or maybe we... Yeah. Okay, then thank you very much,
right.
and enjoy
Thank you, guys.
conference.
Have a great conference.